Welcome in Dark Core. A team of astronomers discovered a supernova explosion in a galaxy nearly 4.6 billion light-years away from Earth, and it's brighter and more powerful than any other in history. The supernova, named SN 2016 APS, is so powerful that its type has only ever existed in scientific theory, at least until now. It's the single brightest supernova ever observed and was caused by a colossal star between 50 to 100 times more massive than the Sun. Before we dive into more details about this fascinating discovery, you might be asking, what exactly is a supernova? Put simply, a supernova is a result of a sufficiently massive star exploding at the end of its lifespan. Supernovas occur quite frequently in the Milky Way, with a new one happening every 50 years. There are multiple types and subtypes of supernovae, but most involve a star at least 8 to 15 times more massive than the Sun. There's a lot more we can talk about when it comes to supernovae, and we'll get back to them later. But right now we'll check out this new historic supernova discovery. The supernova SN 2016 APS, or SNAPS for short, was discovered by an international team of astronomers using observations from the Panoramic Survey Telescope and Rapid Response System, PAN-STARRS, in Hawaii. They also used data collected by the Hubble Space Telescope, the Keck and Gemini observatories, and the MDM and MMT observatories. It was initially found back in 2016, with a team spending 2 years observing the distant supernova as the light from its explosion continued to fade. The team believed it's an example of an extremely rare event known as a pulsational pair-instability supernova, which is caused when huge amounts of stellar ejection material from an exploding supernova collide with a giant chunk of gas shed by a star many years before. Also, supernovae resulting from such collisions produce explosion energy that is massively powerful, much larger than normal and brighter beyond any type of supernova. Matt Nickel, the lead author of the study that discovered the supernova, stated that in a typical supernova, the radiation is less than 1% of the total energy, but in SNAPS, radiation was found to be 5 times the explosive energy of a normal-sized supernova, throwing off the most light ever seen. 5 times might not seem like much, but it is, for a better word, astronomical. Using the measurements they gathered over 2 years, and while the supernova faded to about 1% of its peak brightness, researchers were able to calculate the mass of the star that produced this exceptionally bright supernova and found it to be between 50 and 100 times greater than the Sun, another astronomical feat. But exactly how did the star get so big? The team believes it has something to do with the fact that the star had a lot more hydrogen than usual. Nickel explains that such a massive star would have lost its hydrogen from stellar winds long before it started pulsating. Nickel also provided a possible explanation as to how the hefty star came to exist. One explanation is that 2 slightly less massive stars of around 60 solar masses had merged before the explosion. The lower mass star holds onto the hydrogen longer, while combined mass is high enough to trigger pair instability. The discovery of this supernova provides a lot of opportunities for further research in the world of astronomy and astrophysics. Its existence allows other astronomers to find answers to questions about early stars in the universe, particularly about how they died. If you don't follow astronomy news, it may not seem like much, but it's a big deal, and it came at a great time. Vito Burger, a fellow author on the supernova study, said that finding this extraordinary supernova couldn't have come at a better time. Now that we know such energetic explosions occur in nature, NASA's new James Webb Space Telescope will be able to see similar events so far away that we can look back in time and see the deaths of the very first stars in the universe, and that'll be an incredible moment in history. There are a few different supernova types, some more common and some exceptionally rare like SNAPS, but the 2 most common types are either Type 1 or Type 2, with some subtypes under both. Type Ia supernovae are caused by a white dwarf in a close binary system, which means there are 2 stars or objects in the system and they are close to each other. The white dwarf, which is already incredibly dense, slowly drains the gas and matter from its neighboring star, becoming even denser as it continues to accumulate more and more. It eventually undergoes a runaway nuclear reaction, causing the star to explode violently. Similar to how our Sun will die, the star will eventually burn through its hydrogen and helium reserves. However, while the Sun will simply burn out and turn into a red giant, taking Mercury, Venus, Earth, and Mars within a fiery apocalypse, the Type Ia star is massive enough to take a different course. Before going supernova, the star builds up heavy elements at its core, effectively growing its mass. After the mass reaches a critical point known as the Chandrasekhar limit, it implodes. The implosion causes a star to become even hotter and denser, then eventually it explodes, also in a gloriously violent manner. Type 2 supernovae often occur in large stars that are at least 8 to 15 times more massive than the Sun. After a giant star burns through all of its hydrogen, it begins to start fusing increasingly heavy elements in shells around its core. At some point, the energy produced by the fusion process in the core isn't sufficient to overcome gravity, and the core collapses. If an outer envelope of hydrogen still exists around the Sun, the core collapse will ignite a fusion process in a layer of hydrogen, triggering a massive supernova explosion. If the star is around 20 to 50 times more massive than the Sun, there's a chance it'll either explode and leave nothing behind or collapse in on itself and become the most mysterious and chaotic object in the known universe, a black hole. With all this talk about supernovas and their destructive capability, is Earth in any danger from one? Are any of them close enough to affect us? What would happen if we were too close to one? All the supernovae discovered so far aren't exactly close to Earth. Most are so far away that when observing them, we're actually seeing them as they were millions or even billions of years ago. The last supernova close enough to be seen with the naked eye was supernova 1987A, spotted in 1987, and was around 168,000 light-years away. There are about 6 different supernovae relatively close to Earth, but none really pose a threat as of now. The closest known supernova to Earth is Ik Pegasi b, which lies 150 light-years away, a seemingly safe distance from us. But are any of them close enough to negatively affect us? Scientific studies have managed to calculate the minimum safe distance the Earth needs to be from a supernova to prevent any damage, about 100 light-years away. Astronomers are monitoring a few suspects, notably Betelgeuse, because of its recent dimming, but none are close enough to Earth to make a difference. Betelgeuse is a red supergiant star in the constellation of Orion that is roughly 1,000 times larger than the Sun. If you put this solar giant where the Sun is in our solar system, its surface would lie beyond the asteroid belt and would engulf the orbits of Mercury, Venus, Earth, Mars, and perhaps even Jupiter. It's estimated to be about 724 light-years away from Earth. In October 2019, the red star began to get unusually dim, and during January and February of 2020, its brightness reached a record low of just 40% of its usual level. It's well known that Betelgeuse is a mature star that will someday go supernova. The recent dimming has led to speculation that a supernova could happen at any moment, and what we could be seeing is a calm before the star expires in a cosmic blast. However, the star recently returned to its previous brightness. When it does go supernova, from Earth it'll shine as bright as the half-moon, or 9 times fainter than the full moon, for more than 3 months. Everyone on Earth will notice an incredibly bright light that you could easily see in the sky on a clear day, and it would cast shadows like the moon at night. We could be able to see the supernova like this for roughly a year, and it would be visible at night with the naked eye several years after the explosion. But we may have to wait 100,000 years for that to happen. It's still very far away from happening, but is there anything closer to us? Currently, estimates suggest that supernova explosions happen within 33 light-years of Earth around every 240 million years. So what would happen to the Earth if it was subject to an event like this just 30 light-years away? The supernova explosion would unleash massive levels of X-rays and gamma rays that would bombard the planet and melt away the ozone layer. Once the ozone layer is gone, Earth would be exposed to dangerous levels of solar and ultraviolet radiation. The result would cause a mass extinction, including the destruction of phytoplankton that generate around half the Earth's oxygen, as much per year as all land plants combined. Our Sun is a fun source of speculation for the effect of a supernova on Earth at such a close range, but that will never happen. If the Sun did go supernova in some alternate reality or dimension, it would undoubtedly obliterate the Earth from just 92.9 million miles away. But instead, when the Sun runs out of hydrogen fuel, it will slowly expand and become a red giant, shedding its outer layers and then becoming a compact white dwarf star, which will slowly cool down over trillions of years. Although this event is billions of years away, the Earth will eventually be vaporized. Supernovae are simply fascinating and beautiful astronomical objects. They've already provided plenty of insights into the universe and its evolution. Finding the brightest supernova in history has helped us understand them more, and now we may witness a supernova with our own eyes. Imagine a large population of the world staying up and staring at Betelgeuse, just waiting for the light show to start, and a cheer going up around the planet when it finally does. It could happen at any moment. When it does, you'll see it here. So make sure you click subscribe and turn on notifications, and you'll be the first to know when we release a new video. Thanks for watching Dark Core.